We are next going to move on to our the last talk of this session. So this talk is going to be given by Sarah Kelly, who is part of the VEuPathDB team. Sarah, do you want to start sharing your screen?
Yeah.
All right, well, you can do that while I give a brief introduction. So Sarah Kelly is part of the ClinEpi and vector-based team, which is part of VEuPathDB, and that's based at Imperial College London. So today she'll be talking about ClinEpiDB, and ClinEpiDB integrates data from epidemiological studies and then offers tools and visualizations to explore the data within a browser in a point-and-click interface. So Sarah, feel free to begin.
Thank you.
Hello, I'm Sarah Kelly, and I will be giving you a brief introduction to ClinEpiDB, which is part of VEuPathDB, the umbrella group that also hosts the genomics sites of PlasmidDB and VectorBase, which some of you may be familiar with. I work across the ClinEpi and VectorBase groups in the outreach and curation teams, and I'm based at Imperial College London. A few years ago, the VEuPathDB team started encountering clinical and field datasets that are comparable in scale to genomic datasets. For instance, a malaria project in Uganda collected genetic data on both people and parasites, as well as entomological data, clinical samples, and socioeconomic information on study participants. There was a need to accommodate these diverse data types into a practical interface for epidemiologists, parasitologists, and clinicians working on this project. A pilot database was quickly created, and it became what is now the ClinEpiDB platform. In ClinEpiDB, we host data at the community, household, participant, and sample level, which also includes entomological data at the household and community level. We often get asked by study teams, what do we stand to gain from submitting our data with you? The answer is this. We are lowering the barrier to make data open access. It is often a requirement for journals these days for your data to be open access. Greater visibility of your work, which can help you to foster collaborations between research groups. It can promote data sharing and support secondary data use and accelerate discovery in the field. I will now give you a live demo of our new and improved beta ClinEpiDB site. We are now looking at the homepage of the beta ClinEpiDB site. In the header, you can find more information about ClinEpiDB and our frequently asked questions. Under the Studies tab, you can see the Study Summaries table. This table gives a brief overview of each of the studies available in ClinEpiDB. The disease is clearly indicated with a letter inside a bright colour to indicate the disease the study focuses on. Here we can see all the malaria studies available in ClinEpiDB. It lets you know the investigation type, study design, the number of participants, the country and the years that the study was conducted in, and the study accessibility. You can access the data by clicking on the link under the Study column or the icon under the Explore and Analyze column. You can also access this data directly from the homepage. Just a note to say that on our main ClinEpiDB site, there are many more studies available. There are 13 malaria studies, but there are less new cool features that I am going to show you as we go through the talk. Under Explore the Studies, you will see the Find Studies search box. I will type in malaria, so that shows all the malaria studies available in ClinEpiDB. I'm going to look for a study that I would like to work on today, and I'm going to pick the PRISM 2 isomer cohort. The study card gives you a little bit of information about the investigation before you click onto the main study details page. It shows you the type of study, the number of participants, and a brief summary. We click on the study details page. You can see that unlike traditional data repositories, we integrate data into our resource and make it available through your internet browser. On this page, you can see the diagram at the top. This shows you the shape of the data and the sample sizes. We can see here that there are 80 households with 531 participants, meaning there was more than one person from each household in the study. There were 36,565 variables that were collected more than once on the participant. 36,565 samples collected in the participants. We also have household repeated measures, which means there were variables that were collected more than once at the household level. On this page, you can see the primary publication and primary contacts. You can see a description of the study, and you can find all the study documentation that is associated with this investigation. At the bottom, you will also find all the collaborators associated with this study. We now want to click on the Browse and Subset tab. At the top here, on the left, you can see the featured variables. These are the variables that are deemed most important by the study provider, by the data provider. These can be amended to suit whatever the data provider would like. We also have this starred variable. We might want to star our favorite variables. For me, I might star age group and age, and I might star Plasmodium by qPCR, just because I might want to use these later. What this does is enables you to just display your favorite variables in the variable tree. If you switch this off, then you will see all the variables. I'm going to open up this variable tree so that you can see what we have for this study. I'm going to show you an example of how the continuous variables look in the variable tree. So we're going to look for age. Age, we can see, is a bimodal distribution because it enrolled children under 10 and then adults in the household. You can see that the continuous variables are displayed as histograms. You now might want to find a categorical variable and see how this is displayed. So we're going to go for malaria diagnosis and parasite status. Here we can see that instead of a histogram, we have a bar plot. We can see that 39, that less than 1% of the participants had malaria, 2% had asymptomatic parasitemia, 88% had a negative blood smear, and 10% the blood smear was not indicated. Now we might want to visualize some of our data. Go to the Visualize tab and click New Visualization. You have various different plots which will be suitable for different types of analysis. I'm going to click on the mosaic plot R by C table. I'm going to select the x-axis. I'm going to show my favorite variables. I'm going to use age group. I am then going to pick another favorite variable, pick Plasmodium by qPCR. Here you can see that this is given as a visualization of the Plasmodium by age group. So here we can see that the highest rates of Plasmodium was in the age group 5 to 15 years, with 14.3% positive for Plasmodium and 85.7% negative. This was followed by the 16 years or older, with 11% positive and 89% negative, with the lowest numbers of positive plasmodium in the under 5s, which were 4.2% positive and 95.8% negative. You can see on the left, you also have the p-value, degrees of freedom, and chi-squared. So you can see in just a few clicks, I was able to ask a question of this data and make a plot. This is a demo of how ClinEpiDB simplifies data exploration. I'd like to say a very quick thank you for listening, and please do reach out to us at help@clinepdb.org or via our Twitter account @ClinEpiDB.
Great. Thank you so much, Sarah, for sharing that. It seems like a really, really good tool for this community. I guess just I had one question, like how long does data stay up there, or is it just like permanently on the site?
Yeah, it's up there as, I guess, as long as the data providers would like it available. Yeah, so we make it available from when the data provider would like it, which can be when they releasing their data in a publication or before, and then it will stay on the site for as long as they would like.